Okay, graphing linear inequalities. These are kind of a mix between graphing an inequality and graphing a linear equation or a linear function. So we're going to be putting inequalities on a two-dimensional coordinate plane rather than just a one-dimensional number line. And to graph a linear inequality, it works just like a linear equation. So you can use y equals mx plus b, but there are rules for the inequality part, the shading part. So if an inequality uses less than or greater than, we're going to use a dashed line or a dotted line. And this is to show that the points on the line are not included in the solution, just like an open circle on a one-dimensional inequality graph. So it's going to look something like this. Now if the inequality has the equal to bar, so less than or equal to or greater than or equal to, we're going to use a solid line for that. So it'll just look like a normal line. And this is to show that these points are included in the solution, so it's kind of like the closed-in circle on the one-dimensional number line. So that's the type of line. Now to know where to shade, if we have y is less than or equal to, we will shade below the line. And if we have greater than or equal to, we will shade above the line. And this is to show that the possible solutions of this inequality are either below or above the line, depending on the inequality symbol. And don't forget, if you divide or multiply by a negative when you're solving, you got to flip that inequality symbol. All right, let's do some practice. So we're going to graph each inequality here. The first one we get to actually breaks the rules that we just set out, because this is the only type of inequality that starts with x, or this type that starts with x is the only kind that doesn't follow the same sort of above or below rules. So remember, x equals 3 is a vertical line through 3 on the x-axis. So we're going to graph that same line, but we'll follow the rules for inequalities. So this has the equal to bar, so we'll be using a solid line. Solid line there, vertical line, through 3 on the x-axis. And then it's greater than or equal to 3. So in x, instead of going above and below, because you can't shade above or below a vertical line, we go left or right. And the direction that x increases in is to the right, so we're going to shade right here. So all these points are solutions of the inequality, including the ones on the line, because they make the inequality true as well. Okay, example B, we have y is less than negative 3/4 x plus 2. So start graphing this part just like a regular line. This is the mx plus b. So we start at 2 on the y-axis. That's our b value. The slope here is negative 3/4, so down 3, right 4. Keep doing that. You can go back to the middle and go up 3, left 4. That's the same line. Now once you have your points planned out, before you draw the line, you have to decide what type of line. Our symbol here is less than, so it doesn't have the equal to bar, so we're going to use a dotted line or a dashed line. And this is to show that the solution starts here but does not include these points. And since it is less than, y is less than this line, we're going to shade the direction in which y decreases, so below the line. All these points. So all these points are solutions for the inequality, just not the ones on the line. So if we were going to name some solutions, we could name 0, 0, negative 5, negative 5. Any point that's in this shaded area is a solution of this inequality, just not the points on the line. Let's keep going. Example C, 2y minus 4x is greater than 6. We have to solve this one first. We have to get y by itself. So we're going to add 4x to both sides. So we'll have 2y is greater than 4x plus 6. And then our final step here is to divide everything by 2. So y is greater than 2x plus 3. And there is your inequality in slope-intercept form. Let's put it on the graph. So we start at 3 on the y-axis, that's right here. Slope is 2, or 2 over 1, so up 2, right 1. Or down 2, left 1 from that middle point. Putting more dots on the graph gives you a better line, better looking line. Now it says y is greater than. So again, we don't have the equal to bar, so we're just going to use a dotted line, dashed line. And then y is greater than 2x plus 3. So that is shaded above the line. So the inclusion or the presence or absence of the equal to bar tells you whether it's dotted or solid. And then the shading is whether it's greater than or less than. Example D here, we're going to subtract x. Negative y is greater than or equal to negative x plus 3. Again, write that x term first because you do want slope-intercept form. Final step here is to divide by negative 1 to get y by itself. Don't forget to flip your inequality symbol because we divided by a negative. So less than or equal to x minus 3. So we start at negative 3 on the y-axis. Our slope is positive 1, that's 1 over 1. Now I'm going to skip every couple here just because it'd be a lot of dots. But up 1 over 1 or down 1, left 1. There we go. And we do want it to be a solid line this time because it does have the equal to bar. So a solid line like that. And it says y is less than or equal to. So we are going to shade below that line. Less than or equal to. All right, moving on. For this example, we graph an inequality, 5x plus 7y is greater than or equal to 10. And then we have to determine which of the following order pairs are part of the solution. So let's start by putting this in slope-intercept form. First thing to do is to subtract the 5x. So 7y is greater than or equal to negative 5x plus 10. Everything gets divided by 7. And y is greater than or equal to negative 5/7, just leave that fraction. And then here we have 10 divided by 7. And this isn't ideal, but we can work with it. Let's just write it as a decimal here just to make it easier to graph. It's about 1.4, 10 divided by 7. But you could also just leave it like that, or you could write 1 3/7. But the goal here is to be able to graph this easily. And so in this case, having a 1.4 makes it a little easier to graph. 1.4 is about halfway between 1 and 2. And then we go down 5, right 7. Well, stay in the middle. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7 is out here somewhere. And then up 5, left 7. 1, 2, 3, 4, 5. 1, 2, 3. Out here somewhere. So not the best looking graph, but it works just fine. So it should look something like this. We do use a solid line because of the equal to bar. It's greater than or equal to. And we shade above for the greater than part right there. So now we have to determine which of these points are solutions. Well, negative 2 is down here. And that is not in the shaded region, so nope. 1, negative 1 is here. And that's not either, so that's not a solution. 1, 1 looks like it just made the cut. That is inside the shaded area. And 2, 5 up here, that makes it as well. So these two are solutions. So it's all the points that are in the shaded region. Okay, last section here, we're going to just go backwards. We're going to write a linear inequality, which is represented by the graphs here. So we have to find the y-intercept, the slope, and then we have to decide what the symbol is based on the type of line and where it's shaded. So the y-intercept here is 4, and our slope is negative 2 over 1, which just equals negative 2. So let's think about the symbol. We know that it's shaded above the line, this area here. and we know that it is a dashed line. It's not a solid line. So those two things together tells us that it is greater than. Greater than for the above, and don't put the equal to bar because it is dashed. And then we just fill in the rest. We got negative 2x, that's our slope, plus 4 for the y-intercept. There is the inequality. Example B, same thing. Let's find the intercept. It is 0. Slope here is up 1 over 1. So that's 1. Let's get to it. We know it's shaded below the line, right? So that's less than. It's a solid line, so less than or equal to. And then we got 1x plus 0. And to simplify that a little bit, less than or equal to x, and that's it. So y is less than or equal to x. Example C. This is a horizontal line, so it's going to look pretty simple. Our intercept is 5. Horizontal lines have a slope of 0. So let's go ahead and do this. It is above the line, and it is a solid line. So greater than or equal to 0x plus 5. Well, we can simplify that to just greater than or equal to 5. Last one, slope and intercept. So the y-intercept here is 1. And the slope looks like it's negative 1, down 1, right 1. So negative 1 for the slope. For the symbol, it is shaded below the line, so that's less than. It is a dotted line, so we're not going to add the equal to bar. And then we've just got negative 1x plus 1. Or to simplify, less than negative x plus 1, just like that. And that is all for these notes. So basic concept, graph these the same way you graph normal lines. Just remember what type of line to use and where to shade the graph, both based on the inequality symbol that is given to you in the problem.